for doing this. It's not dumb. It just shows you how much you remember from your previous stuff. So today we're going to identify linear versus nonlinear. So in previous lessons, we talked about linear functions are straight lines. If you graph that line using a ruler, that's linear. And it's linear because the rate of change between any two data points is constant. Remember that way back in 3-1 when you'd have to do the swoops and you'd have to say, this is linear because the rate of change is constant at blank. Okay, so linear means it's a line, means you have a constant rate of change. Constant means the same. Okay? Linear means the graph looks like a line and you have a constant rate of change. On the flip side, nonlinear, the rates of change are not constant, or in other words, not the same. And their graphs are not straight lines. In other words, they are a curve. There's a bump in the road someplace. Okay? Look down on that page. Does it look familiar? You done this before? Looks exactly like 3-1, does it not? Like we do those swoops? Yeah. Okay, and we do negative 15 over 2, negative 15 over 2, negative 15 over 2. And we look at these, we're like, oh my gosh, they're all the same. The rate of change is constant, so this function is linear. They're the same. Versus this one, you'd have 15 over 3, 33 over 3, and 51 over 3. Well, 15 divided by 3 is 5. 33 divided by 3 is 11. 51 divided by 3 is 17. Are those the same? No. The rate of change is not constant, so it is non-linear. You're going back to swoops. So let's go down to A. Start with your X. How do I go from 0 to 5? Plus 5. And 5 to 10? Plus 5. 10 to 15? Then we go down to the Y's. 20 to 16. 16 to 12. 12 to 8. Okay, now here's the tough part. Which number goes on top? Y, which in our case is the bottom. So negative 4 over 5, negative 4 over 5, negative 4 over 5. What are you going to tell me? This is linear. Linear because the ROC is constant. Linear because the ROC is constant. Try B on your own. Try B on your own. What'd you get on this one? You got a 1, a 3, and a 5. So what's your answer here? Non-linear. Because the ROC is not constant. It's like we've done this before. Yeah. 3-1. This is linear. The rate of change is constant. That's chapter 3. Okay, I want you to go to page 328. Number 3 says the table shows the measures of the sides of several rectangles. Are the widths of the rectangles a linear function of the lengths? You're just wanting to know, are they linear? Guided practice. Guided practice, 330. Did I? I'm sorry, 330. 330. That was my bad. When they give you a table like this, which one's X, which one's Y? The bottom is y and the top is x. Determine for me if this is linear. So I got negative 48 over 3, which is really negative 16, right? Negative 8 over 4, which is negative 2. Do I even have to divide negative 1.6 by 2? No. If these two aren't the same, who cares what the third one is, right? So on this, what are you going to tell me? Non-linear. Very good. Because the ROC is not constant. Okay, so the main summary is you're still looking at slope. You're trying to determine if the rate of the change is the same. Here's what screws people up, okay? On a linear function, if it's graphed, it is going to be a line, okay? It's going to be a line. If it's not, it's going to be a curve. Like, it's not going to be like this tiny little bump that you have to look for. Like, it's going to be very obvious that it's not drawn with a ruler, okay? Somebody this morning's like, well, like, could it be just like a little bump in it? No, it is going to be super obvious that it's a non-linear versus a linear function, okay? That's it today. Page 331, here's your homework. I jump all over the place, so get ready. 1 through 6, 8, 12, 20, and 21. 1 through 6, 8, 12, 20, and 21. You have the rest of the hour to work. Then you can work on other homework if you get done.